to start off now. What I would like to do is first go around what we've got going on here by giving you introductions of the CommTech team and our partners that are here as well with us. So here on the CommTech team, we have my colleagues Mark Yamamoto, Tom Sheehan, and Will Cruz. We have our partners from VSAT who make the antenna system that is on the boat, as well as make the tracking system for the landside, shoreside tropo comet system, Elias and Jared. And then we also have our partners from micron who make the feed for the comet as well as the fixed antennas, and that is Dasha. My name is Paul Scardino. Again, thank you very much for coming. What we're showing you here is a demonstration of the full capabilities that CommTech communication systems can provide for bringing tactical voice, video, and data to the edge. What you see starting from the right hand of my screen is our satellite gateway in Tempe, Arizona. The signal is going over the satellite, and they're providing internet connectivity over the satellite to our two terminals, which we call recon. Following those recon terminals, it is connected by Ethernet to a shoreside TROPOSCATTER terminal, which is connected by TROPOSCATTER out into the Atlantic Ocean, probably about 60 miles now. They're heading inland now. But having full communications with our colleague Tom Reed, who is on the boat, and I failed to mention Charlie and Jeff from Microrant, who are captaining the boat. So what I'd like to do is walk you through this system, and then we'll turn on the video and we'll show you exactly what's going on. First, we'll hand it off to Will Cruz.
I'm Will Cruz, the product line manager for SATCOM services for CommTech. What we got going on today is we're displaying our recon terminals. It's a new product that we're developing and trying to get this product out to the customers. It's a family of terminals. We offer different variations. We have a 75 centimeter, a 98 centimeter, a 1.35 meter, and a 2.4 meter. Once again, we're offering it as a family of services. We're going for a very modular design with these terminals. What I mean by that, and Nathan can follow me a little bit. In the back of these terminals, these are our RF transceivers. The reason why we went for this design is that they're modular and they will fit on all of the terminals across the family. So meaning I can rotate, pull out, and put it on any of the antennas I want. So that's one of the big benefits. We're also going with your audio on. Okay. We're also going with the tripod design to keep this low profile to the ground. And the purpose of the recon in this demonstration is we are currently pulling internet services from our department that's called EF Data. We're pulling internet through this terminal. And we're utilizing their modem, which is called the 5650 Charlie. Basically, what we're doing is a clean FDMA shot. But I do want to give you a little bit of information about this modem because it has a very interesting function. It's called DSSS. And what that function does is it allows us to spread our carrier so far that we're undetectable underneath the noise floor. And it's also for anti-jamming purposes. This modem is capable of handling up to 155 megabits per second of data. And as you can see, it's got a low profile. It's very small. It's the smallest ODU unit out there. And that's what we got going on. And the second terminal, we have it as a receive terminal, just so that we could show the customers here, what our link looks like. And then we brought our FDMA link down, and then we brought up DSSS, and everyone saw how it was just the noise floor, but they saw that our modem was up and we could get to the internet. So that's the recon aspect of it, and to include the modem. So from here, we're going straight to the Comet, and with that, I'll go ahead and tag in Mark Yamamoto.
I'm Mark Yamamoto from CommTech Systems. I'm the product line manager for all our Tropo systems. And today I'm going to share with you what is making this possible, that we can communicate over 50 miles out to a moving platform or a boat. What really makes this possible is our CS67 Plus radio. What you see here is our standard COMET system, which is part of our family of TROPOSCATTER systems. This is a 1 meter reflector with about 32 dBi of gain, and we get about anywhere from 60 to 100 kilometers. So the CS67 Plus TROPOSCATTER radio went into full production in 2016. This is the smallest TROPOSCATTER full quad diversity radio in existence. It's Ethernet in and 70 megahertz to 6 gigahertz output. So currently, the COMET system that uses this radio, along with all our other TROPOSCATTER systems, we're currently in the 4.4 to 5 gigahertz band. The COMET is packaged in two airline checkable transit cases. Each case weighs in at about 50 pounds. The actual terminal weight when it's set up is 52 pounds. We've watched Marines and soldiers set this terminal up and be online communicating with the distant end in 15 minutes or less. And we've done links fully obstructed in urban environments out to 3-4 miles to links clear out to 95 miles. We did a link from San Diego to Los Angeles that was 95 miles, and we were getting 112 megabits. So what we did is, from the COMET, we decided let's add a tracking pedestal. And with that, I'll turn it over to Elias from the BATS team to discuss the tracking antennas that we're using for this full motion on the move capability.
First of all, I'd like to thank everyone here, and especially Comtech for inviting us in this event. Truly, it's been an honor to work with you guys, and appreciate the opportunity. BATS has been around since 2007, and we're a small business, originally born to provide terrestrial point-to-point communications with high directional antennas. As Mark is sitting in front of the terminal right now, we have our tracking system. This is a pure line-of-sight tracking system that is been proven out in commercial world for maritime use, as in cruise line industry, ferry, ship-to-shore comms for oil and gas, and here, as shown, we are using this tracking system as well to enable troposcatter communications. And I'd like to move to the solid state side of the technology, where in our defense side of the business, we've developed this new technology. It's an electronically steered antenna that utilizes, in essence, the same software that is in our tracking systems, but in a more obviously compact and more mobile product. The vision for BATS for this particular product is basically to remove omni-antennas on the battlefield. And today we are showing that we can do that in not just in point-to-point communications, but we can do that in MANA mesh and point-to-multipoint communications as well. The technology itself has the ability to create single or multiple narrow beams and track those beams as moving platforms such as Stryker vehicles, Humvees, and so forth. The nature of it being small, lightweight, of course, is showcased even in this demonstration, where we have installed the antenna on a 50-foot boat and have enabled the communications out to sea with up to 70 miles today. Another key point with this antenna is that it is an IP device, and if we can pan here, we can show you the UI that is basically based in the antenna, and this is a feed from the tracking system, and this is a digital feed from the solid state antenna. Both UIs are providing real-time feedback from onboard sensors that would be resident on the antenna. In addition, we are providing pitch information of the boat. And as you can see here, this is a real-time pitch feedback from the boat, as well as a direction of beam steering for the solid-state antenna and direction for the tracking system to the boat. In addition, we're able to pull speed and location of the particular boat at that time. So our products, in essence, have enabled on-the-move communications for commercial and military applications. For this, I'd like to now move over to Dasha, who's going to talk about the specialized antenna.
My name is Dasha. I'm the Director of Business Development at Micron LLC. We have been working together with CommTech on the common TROPOSCATTER system. We're a custom antenna design and manufacturing company, and what we have contributed to this beautiful technology is the CMAC feed, which is a high-efficiency backfire system which enables this entire pedalized reflector solution to work. We're continuing to work together with CommTech to develop more different solutions that will be able to perform really well in different environments, including a circularly polarized feed, for being able to use this in marine environments or on platforms that are unstable, together with a positioner, as well as developing a split beam design for use in urban environments where you want to create more multi-count capabilities in order to get the signal across a highly blocked environment.
We're going to switch over to Tom Sheehan. He's going to talk about the network on the boat and then hand it off to Tom Reed, who's going to show you video from the boat.
Thank you, Paul. Comms check, just make sure everyone can hear me all right. I want to thank Dasha and Jared and Elias for coming out and helping us support this. It was a big event. What we conducted today is a full-on demonstration of TROPOSCATTER on the move, as Mark had mentioned. And so what we've done is we're located here in Melbourne, Florida, and the boat was started out its day today in Fort Pierce, Florida, and started to move offshore this morning about 9:30, 10 o'clock this morning. On the boat, as mentioned, is the BATS mobile antenna with the Comet base station on it, and we turned the system on this morning, and as soon as they started to move out offshore, approximately 3 or 4 miles offshore, we were able to establish connection. What you're seeing right here is this blue arrow is the boat and its current heading, and this green line represents the path from the boat to our shore station up here, where we are standing right now. This morning, right now, you can see the boat is about 50.8 miles away. This morning, the boat tracked all the way out here into the Gulf Stream, and then when it was about 49 miles out, started a southeasterly track. And what we kind of did was just take some anecdotal measurements of the throughput and the distance that we had. So throughout the morning today, we started out, we were getting, right when the system linked up, we were running about 10 megabits of throughput. And that was out at 45 miles. Then we traveled along and we got out to 50 miles, and our throughput, as we got a little bit further away from land and out of the shadow of the landmass there, our throughput actually started going up. So for a good portion of the day, from 50 miles going out, we were averaging in the neighborhood of 17 to 18 megabits bidirectionally between the mobile station on the boat and the tracking station here on land. We were operating in our 10 megahertz bandwidth with 2 times DSSS times 2, which basically takes that 10 megahertz and separates it out spreads it out over the channel. And basically what we're using is putting out about 4 watts at the antenna to get these throughput values. Same on this tracking station antenna and on the boat antenna. The boat proceeded for the remainder of the morning to continuously move away from our shore site, and we got out to a point where we got out to 70.2 miles when the link finally dropped off, and we did that on purpose. We wanted to absolutely test this system to link failure and see what true distance we can get. So at 70.2 miles, that's about 112, 113 kilometers. Even all the way out while the boat was moving, and if you take a look at this bottom graph, this graph represents the pitch angle of the boat in motion. And so you can see that each one of these spikes is a pitch up on the bow, and each one of these spikes down below is the bow pitching down. So we had a fair amount of pitch movement in motion while the boat was traveling. All the way out 70 miles, we were able to still maintain some connectivity where we were running about a megabyte or 2 megabytes of throughput while the boat is on the move at about an average of 10 or 11 miles an hour. Continuously throughout the day, as you see on your screen right now, this is a Polycom video that we've been running all morning between our workstations here on the shore site and on the boat where my colleague Tom Reed is. And speaking of Tom, he is joining this or participating in this Teams call actually through this link over the satellite service and connecting to the internet in Tempe, Arizona, as Will explained earlier. So with that, we'll go ahead and ask Tom to turn his camera on for a few minutes, and maybe he can pan around and show you around the boat and out to the side there while we talk through some of the other details of the demo.
Yes, Tom Reed, Comtech Systems, as Tom Sheehan was saying. We're currently on the boat after, like Tom said, after we hit the 70-mile mark, we have made a turn, and we're currently headed. We have about a 310-degree heading northwest now at about 10 knots. But yeah, as you can see around the boat, it is a live feed from this just through Teams, just using the internet services being pulled in from the recon system. Currently, everyone on the boat is connected to the internet services. So we have myself and 3 other members on the boat, all utilizing the data services connected to our phones. It's all been concurrently with that, and also with the, like Tom mentioned, the live Polycom video going at the same time. We haven't had, ever since we initially broke the link at, we maintained the link, like Tom said, all the way up to 70 miles. There was no interruptions and even severe pitching of the boat. The only time it broke was when we hit the 70-mile mark. We made our turn, reestablished the link, and again have maintained the link throughout. And currently it's a lot calmer than it has been over the last couple of days testing. It was a lot choppier out here, and still, even through that, we were able to maintain link connectivity, all of our data services with no interruptions.
Yesterday, while we were running this exact same test, as Tom mentioned, the other crewmates on the boat connected in to use the services. So not only were the other people on the boat using the services to make wireless IP telephone calls, they were sending text messages and actually conducting some basic office business while they were on the boat throughout the day. But the other thing that was interesting is that Charlie also connected up his SIMRAD navigation chart plotters to the internet service. And while he was out there and everyone was using it, he was actually downloading maps and updating maps on the chart plotters. So the point to that is that we've kind of illustrated here that you can have real world services extended significantly far distances beyond line of sight while on the move. Right now, the boat has been coming back at us for the past hour, hour and a half. They're approximately, they're 49.5 miles out. And right now we are connected and we're reaching through using one of our more stable speed settings. We're getting about 1.5 to 2 megabytes, 3 megabytes of traffic through. One of the important things that we tested today was our DSSS. As we got out to the far end just before the link broke, there was a fair amount of time when we were operating, our RSL levels were neg 101, neg 102. We were actually operating and being able to pull our signal operating in the noise floor, and our systems are able to sense that and reassemble the signals and make an intelligible data transfer. So as Mark mentioned earlier, that's one of the big powerful things that the CS67 Plus radio brings to the game.
I'm going to show you something that we did earlier in the week for those of you interested in comms on the move on vehicles. What I'm going to show you now is a little bit of a different demonstration that we conducted, where we had the satellite terminals downlinking the connectivity off of the satellite from our facility in Tempe, Arizona, connecting it from the recon terminal to the Comet terminal, which is at our location at our headquarters in Orlando. It was connecting to a relay location, Comet, that was 11 miles away, right off of an interstate in the middle of Florida. That relocation Comet was connected then in turn to a Comet with that tracking antenna. And then on the back of a pickup truck, as you see on the right side of my screen, we had that BATS antenna with our Comet terminal, and that BATS antenna was driving down the interstate in the central Florida, and the connectivity there was about 16 miles. So what we were able to achieve and illustrate was having that full connectivity on the move, on a vehicle, in the middle of a congested area of Florida, right through Orlando. There are many large buildings, and it was in the middle of rush hour traffic. So we were getting that full communications, full internet link to that video and to that vehicle.
Paul, if I could just add in there real quick, on the way back, when we got to the far end of that link and we were coming back coming back on the highway, we weren't stuck in traffic going that way. So we were moving the vehicle at highway speed, 65 and 75 miles an hour, moving with traffic and maintaining a link the whole time. So the system is absolutely capable of moving at typical speeds that you would find in not just a ground vehicle but also in the boat, as you can see.
What we would like to do is ask you to send in any questions on the chat line. I will read them off to the different people. And what I'll do is I'll leave the block diagram up just to give you an indication of what we're doing, continuing to do on this test. What's the max system loss Comet is designed to? Mark, you want to take that?
The Comet can handle up to about 205 dB of path loss.
Yeah, I might add that the Comet was designed for a 25-mile run, and over the summer, Mark and Tom, along with the BATS terminal with Elias, did a test on Lake Okeechobee in Central Florida, and that intention was to try to get an on-the-move test going, as well as see the maximum limitations of Comet, because, as I said earlier, it was designed for 25 miles distance. Well, Lake Okeechobee is just over 30 miles long, and Tom was on his boat doing S turns and never losing lock. And when he went 30 miles, they realized that they ran out of lake. They were still full connectivity at what, Tom, 100 megabits per second. So beyond that, they said, you know, we've got to continue these tests and continue the full capabilities. Our CS67 plus radio modem has excellent wavelength communications potential, and we got to push it to its limits, and we did so today. The next question, Joe, comes in, are you encrypted shot to shot? Right now, Joe, we are not encrypted shot to shot. We're pulling over the satellite, but when we do go into the DSSS mode, whether it be over the satellite, we set the waveform to DSSS mode, we're in the noise floor. So we have a spec GAN. That's we're looking at, and we're seeing just noise, and the communication is going across. And Mark wanted to chime in and say something. Go ahead, Mark.
And the Comet system, we don't have the encryption turned on right now. We easily could. It has built-in AES 256 encryption, and it is currently in evaluation for FIPS2 certification, which we expect to have fully from NIST toward probably summertime this year. And with our testing, with our built-in AES, even with small packets, very small packets, we're seeing only about a 3% overhead.
Ramp for higher path loss part of the system. So right now that's someone please mute. Thank you. Right now the BATS terminal can only handle 4 watts of power on the boat, so that's limited, but that's being redesigned to have an increase in power. Obviously, all of you who are involved in communications recognize that the size of the dish as well as the amplifier will increase your power and provide you more distance. These terminals were designed to be tactical terminals. They're designed with 10-watt amplifiers, and using less than 4 watts, as you heard, we were able to achieve these distances. But yeah, we could connect up different size amplifiers to these terminals, or you end up going to larger troposcatter systems. It seemed like the 4 watt with the low antenna gain means there is much super refractivity ducting. I don't know about that. Are we seeing a lot of ducting there? Go ahead, Mark.
That's negative. We're not seeing ducting right now. We're actually seeing a very true tropo environment with rapid fading. This is well beyond the line of sight range. With the calculations of how high this antenna is above sea level, we're at about 12 feet above sea level at the shore side, and on the boat side, we're about 20 feet above sea level. And that equates to the line of sight horizon, or the line of sight range for this would be 12 miles. And so we're well beyond line of sight range. And I believe that this is reacting as a troposcatter link.
Next question, has the system been tested in more challenging weather?
Yes, the system has definitely been tested in a multitude of challenging weather, severe Florida downpours, desert environment out in Camp 29 Palms, California, with the U.S. Marine Corps. So dry climate type area. It's been tested out in El Paso, in another desert environment. It's been tested up in the mountains. So it definitely has been tested in pretty much every weather environment. In fact, we were looking at testing up in the Arctic Circle here in February, but that exercise was canceled due to COVID.
The noise level at minus 102 dBm. Someone said so. So I think yeah, you're correct, right, Mark? Right, Tom? The RSLs were down to minus 102. We had a range of what, approximately -70 to -102, right? That was about the range.
That's correct. And let me move my camera. I'll show you the current receive levels right now on the link that you are just watching the video on. The two blue bars on the left are my receive signals. The two blue bars on the right are the boat's receive signal levels. And you can see right now we're down around going between -105 to -99. This is literally equates to, I am literally getting negative SNRs at some points. This radio will lock up right at 1 dB of SNR. So it's quite spectacular, especially with our DSSS waveform. I can show another screen right now where you can watch the SNRs. And these are the local SNRs and the remote SNRs. Right now, you can see they're really bouncing anywhere from an SNR of 0 all the way up to an SNR of 9. This is also indicative that it is a troposcatter path. You can see the rapid fading up and down.
The next question is, and you can answer this very quickly because you just did it last week. Have you tested in rural areas?
Yes, so last week we had 2 Comet systems, and I was with T-Mobile, and we were out in the bayous of Louisiana near Lake Charles, where several hurricanes had gone through, and they still had cell towers that did not have backhaul. So we tested several sites, we popped Comets up, and we're giving them anywhere from 150 to 200 megabits of backhaul for cellular services in an area that was literally destroyed over a year ago by hurricanes.
Next question from Mike Martin. Have you had the opportunity to test in conditions with high Aurora Borealis conditions?
So the Swedish FMV, that was a very big concern of theirs. They took our tropo systems up into the Arctic Circle, and the northern lights have 0 effect on the troposcatter. We're not that high up in the atmosphere.
Was tracking both azimuth and elevation, and by what method? Monopose, conical, etc. What was your tracking protocol?
So tracking was done in the azimuth only. The elevation was a fixed elevation on the boat side. On the shore side, because it's an electromechanical system, we were tracking both azimuth and elevation, but the elevation profile did not really require a lot of elevation movement. If in fact was practically none. The feeds on the antenna, the electronically steered antenna is basically a MIMO vertically and horizontally polarized antenna, and that is matched as well on the shore side for the parabolic. Hopefully that answers your question.
Tracking systems fully automated. I guess I could answer that, right? Yes, they were. System available or for development. So those Comet systems have been in production for the last 2 years. The standard Comet system that you saw Mark standing by at the deck, the systems that are on the move, well, I guess we're ready to start delivering them. We're starting to couple them together as a productized set. They've been used probably for a year now in our various testing stages. And I think, yeah, we could certainly start quoting them and selling them.
And one thing to add about the Comet system, SOCOM sponsored the JF-12 for the Comet, and we expect a JF-12 for the Comet this month. It's already been to committee. We're waiting for the final report.
We very much appreciate everyone's attendance, and thanks for you that stayed up on a late or Friday afternoon, evening when you didn't have to see our demonstration. And again, thanks for all the kind words. We'll be signing off.